Hello everyone, this is CKR, Group 5. We are presenting the V-22 Osprey in our project. It's presented by myself, Faison Kaba.
Kevin Rajapaksa.
Hello Chang.
Let's get started. Topics that I'll be covering today will be the assembled model. Within the assembled model slide, we'll talk about individual parts made by all our teammates. Next will be the exploded model, where we can see how each part connects to the fuselage. Next will be individual selected parts and conclusion. So this is our assembled model, and in order from 1 through 17, I'm going to go through who made each part. So parts 1 through 3, the refueling probe, the night vision dome, and the landing gear were all made by Kevin. The fuselage and the side skirt fuselage were made by myself and Hunyo Chang. The landing gear was also made by Kevin. Hunyo and I split the engine also. I made the blade. The propeller hub was also made by myself. Joystick was made by Hunyo. The seat was made by Hunyo. The wing was made by Hunyo. The wing box and tail wing box were made by myself. The door was made by Hunyo. And the vertical and horizontal tail was made by Kevin. This is the exploded model of our aircraft. An explanation of why some of us worked in teams is that the fuselage and the skirt and the nacelle were especially complicated parts that one individual themselves could not do. So me and Hunyo decided to take the task upon ourselves to split the work in half, where two minds could work better than one.
I made fuselage section, and fuselage has to be streamlined and symmetric body. Fuselage acts as connection point to all major parts such as wing and horizontal tail, and it has to have space for cockpit and carrying for payloads, and its material is 40% of composite material. I and Faison created this model using CATIA, using GSD, by drawing fuselage cross-section and use multi-section command. This is Osprey wing. Its major component that makes the lift to Osprey. Its wingspan is about 46 feet and its sweep for about 7 degrees. I use NACA airfoil, which is 643-415. It connects to fuselage and holds engine at the tip. I also used GST in CATIA, importing airfoil shape into CATIA and use multi-section to have its shape. After then, I parameterized to modify its shape for design iteration.
Alright, I am Faison Kaba. The next two parts will be made by me. The first part would be the propeller blades. And the Osprey features 6 very large blades, as is iconic with the Osprey. I used a NACA 2412, which isn't the right airfoil, but since that information could not be found, I used a cambered airfoil, as is common with helicopter blades. A heavy twist is applied, and this is because the outside portion of the blade spins much faster than the interior portion, which makes a non-linear lift distribution. So this twist is added to make the lift distribution more linear. A hefty rod extrudes from the blade at the root to connect to the hub, which will be shown next. And this is created in CATIA by importing airfoil points, using spline to create the airfoil itself, and then using the multi-section surface command to create the surface, and then rotational commands to make the twist in the blade. The next part is the propeller hub. This is a connection point between the engine, or the engine mock-up in this case, and the blades, and the holes where the rod from the previous slide insert into the prop hub are shown in red. The prop hub needs to be incredibly structurally sound to counter the immense torque made by both the engine and also the blades. So of course this must be made from a high-strength material, and it was created in CATIA using multiple circular cross-sections and of course using the multi-section surface command to make the surface. This part was made with a high thickness, more so than the rest of the aircraft, to simulate its high strength to counter the torques by the blades and the engine.
Hi, I'm Kevin Rajpaksa, and I'm in charge of making the next two parts. So for the vertical tail, I used a symmetric airfoil, more specifically the NACA 0012 airfoil. And I used this kind of airfoil because of the fact that I needed to avoid creating a moment arm about the aircraft. In addition to that, it will also provide directional stability. And I imported these points from a website, and then I created the other two cross sections using the translate tool, and then I used the multi-section surface to connect all these points. And for the night vision dome, I used a cross-section circle, and then I created the dome-like structure using the sweep tool. The Osprey is a special ops aircraft, so it requires pilots to see at night, which is why I created this part. And to conclude this presentation, I'm going to specify the limitations. So first of all, the Osprey is a special mission aircraft, so we cannot obtain the direct measurements from the internet, so we do not have any measurements. So to counter for that, we used a Sketcher workbench. So we imported some pictures from the internet, and then we used that Sketcher to draw over it. Also adding to that, the interior details were not included because it would be creating the seats would be too complicated as well. When we were doing the assembly design, the connections were not going into the surface very well, so we compensated for that by creating cylindrical rods in the surfaces, and then we used the coincidence and contact constraints to assemble the whole aircraft. Thank you for watching.